An expectant father paces back and forth, producing the position versus time graph shown in figure 2-32 below. Without performing a calculation, indicate whether the father's velocity is positive, negative, or 0 on each of the following segments of the graph, A, B, C, or D. And then calculate the numerical value of the father's velocity for the segments A, B, C, and D, and show that your results verify the answers that we had before. So basically we want to come back to the idea that the velocity for a graph, the average velocity between two moments on a graph, is just always delta x over delta t, which means it's a slope on the xt graph. So really this is asking us which of these have plus or minus slopes. So segment A, B, C, or D. And we look here and we say, well, in segment A, the line is sloping upward. So segment A has a positive velocity. But for segment B, it isn't going anywhere. The line is horizontal, which is a slope of 0. And then for C, we have it sloping upward again, so it's going to be positive. But for D, the line is sloping downward, and so the velocity is going to be negative. We can do a little bit better than that. We can actually say that the slope is greater in part A than in part C. So this is plus and large, and this is going to be plus but smaller. And next we'll go and we'll just verify that. All right, so interval A, which is now the blue one, will have a velocity, which I'm just going to label as VA. These are really always average velocities, but since during each of these moments the velocity is constant, changing only at the integer second part, we're okay with basically pretending it's just the velocity. And it's going to be the change in position, which is clearly 2 meters minus 0 meters, over the change in time, which is 1 second minus 0 seconds, or just 2 meters per second. And then in B, we would have that it ends at 2 meters and it starts at 2 meters, and the clock ends at 2 seconds but starts at 1 second. So this is 0 meters over 1 second, or just 0 meters per second, as said before. In part C, we have that it ends at 3 meters and starts at 2 meters, and it ends at 3 seconds and starts at 2 seconds. So this is 1 meter over 1 second, or 1 meter per second. And then finally, in part D, it ends at 0 meters. I guess I should say it. The father, ends at 0 meters and starts at 3 meters. But the clock ends at 5 seconds and starts at 3 seconds. So this is minus 3 meters over 2 seconds, or minus 1.5 meters per second. And we see that, as indicated earlier, A and C are positive, B is 0, D is negative, and also that C has a smaller magnitude, a lower speed than A, because its slope is lower.